the session. Greeting of the day. In today's class, we are going to talk about the various dies which we are using for doing the sheet metal operations. In earlier classes, we have seen the various sheet metal operations of blanking, piercing, spinning, coining, those things, stitch forming, such various methods of bending, all we have seen. We are doing those things using some various die operations such as a progressive die, compound die and a transfer dies. The name says everything, a progressive die, compound die, a transfer. It is the process which is going to travel between one station to the another station. So that is called as a transverse die. We will see one by one. Number one, I have taken as a progressive die, parts requiring a multiple operations, such as we have done some blanking and piercing operations, 2 holes, and one we have taken as part with what we need, and one we have taken as a scrap items. So likewise, multiple operations such as punching, blanking, notching operations are made at high production rate in the progressive die. Multiple operations are done. Progressive means we are processing more. Multiple operations are done at one station. A single setup, single die, single punch, but operations multiplied. Not for a single die, single operations are not did. It is progressing too. Punching and blankings are done. So therefore, we are naming this as a progressive die where we are doing multiple operations at high production rate. The sheet metal is fed through the coiled strip and different operations is performed at a same station. So this point is important. On end of the same station with each stroke. Same station, single stroke, multiple operations. You see here, in this setup we have a punch, a die and strip. This yellow color strip here. This yellow color is a sheet metal which we are going to punch. What happens? This contains 2 punches. Here, 1 punch we have, and 1 more we have here. So this the large one I am calling this as a blanking punch, and the small one I am calling this as a piercing punch. What happens? I have kept the strip inside. It means I kept the sheet inside. And I am going to do a single stroke operation. Each single stroke operation, when I am doing the forces applied over the sheet, this blanking punch will go for the blanking operations, and we are getting one product here. And this at the same time, on the same stroke, smaller punch will going to have a force there, and we are going to get a piercing product there. So this multiple operations takes place such as blanking and piercing on a single stroke. That is also at high production rate. So that is what I am naming this as a progressive die. So this is how it looks. So some animated image how it can be utilized. So blanking and piercing operations are done through progressive die. Next I am coming to the compound die. The next step. Several operations on the same strip, several operations to be done on the same strip, on the same sheet, by performed in one stroke with the compound die in one station. This is also we are doing a one stroke, one station, but multiple operations one after the other. A compound die, one process has been done, a blanking has been done, then the blanking sheet has been kept inside again on the same, and we are punching for making the cup drawing operations, such as we can able to do. These operations are usually limited to relatively simple shearing because they are somewhat slow and the dies are more expensive. Not like blanking piercing, we are using a little bit a large simple product, not that much heavy designs. Therefore, when the die size is increasing, obviously cost also is getting increased. So for individual shearing operations, we can individual shearing operations, one stroke, one shearing. But the same piece again has been blank displacement has been taken. First we have taken on punching actions, and on the punching actions we are getting one product, and I am keeping the same product again there, and I am doing again punching for the drawing operation which forms a cup when we are changing the die. So accordingly on the machine setup we should alter it, and we are componently we are using compound, multiple compound we are using there. There the multiple operation a single stroke. But here on a single stroke one operation did, but multiple operation can be did by changing the dies. So I am telling this as a compound die. This is one of the type of die useful for making the cup drawing operations. Next I am coming to the transverse die, otherwise called as a combination die. You see, in transfer die setup, the sheet metal undergoes a different operations at different stations. We have, this is one station and this is one station, and here we are going to do one operation, and the same thing strip has been moved here, and again we are doing the another operation. So such how the operation will extend itself to transfer from one station to another station, one station to another station to perform the task. That is what I am naming. So the sheet metal undergoes a different operation. Here may be one blanking operation, here may be one piercing operations, are at different stations which are arranged along a straight line, which is arranged along a straight line, which is arranged along a straight line, and therefore we can able to do blanking and piercing operations. It may be not on a straight line, it may be a circular also. A set of this image shows you a transfer type operations where number of punches are there here. Number of punches are there. The strip has to come, the die has to move from here. This is the die, it is going to move, and the various punching mechanisms will take over on the setup. So transverse die, multiple operations. Few other topics are there to incorporate this forming methods, advance some other methods, such as number one I have taken as a rubber pad forming. This rubber pad forming, you see, we are using instead of die. Die is usually made up of a hard, tough material. In such a way, the punching force to be withstand by this die, and also it should not break, and it should help the sheet which is kept in the middle between the die and the punch to transform or to deform to the required object. So that is a use of die. What I am doing here, in such cases, at sometimes there is a chance of creation of the cracks. When the heavy load is applied, therefore that load can be transferred to the ground, or otherwise if the load is not possible to withstand, the die may break, or otherwise the material may crack. So such failures are possible. Therefore, I am converting those die into a rubber padding formats. You see, in rubber pad forming, one of the die is set in the made up of a flexible material such as rubber I am using here. Therefore, this rubber will resist. So another material of polyurethane also used. So polyurethane was used widely because there is a resistance to abrasions. This will not abrasion wear will not take place. Therefore, it can be utilized for the longer time as like the normal die, and also having a long fatigue life and resistance to the damages. So what is the mechanism here? The mechanism is nothing but, you see, this is the die. So I am writing here, this is the rubber die. Rubber die. This is the rubber die. Rubber die. What happens? Do with respect to punch, we have the die here. I have the product At a green color, it is visible there. At a green color, we have the product here. This is the product. At a straight product I have. Here, this product having the punch having the design as like this format, and it has to be formed. At first, one side punching mechanism has been started, and this rubber pad forming may have the design, punch may have the design, accordingly the punch impression has been created. But to avoid the cracks formation, we are making some flexibility in the rubber pad in such a way it can able to lightly make the cushion effects there. But even though this have to observe the impression, it has the resistance from the other end in such a way only the impression is going to fall on the image. But if it is very rigid, what happens? The transfer of force may be fall on the die and travel to the ground, otherwise die may break. Therefore, little bit cushion effect has been created, and also it resists the force upward direction. Therefore, cushion, no crack formation. At the same time, this withstands the force. Therefore, impressions are created on the specimen. So that is what I have did. Impressions also are formed. Resistance also given here. So resistance also generated here. So here resistance also generated. It resisting somehow. But at the same time, 20% of cushions will be there. Therefore, it can come down in such a way damages on the material, damages on the die can be avoided. So that is the help of rubber pad forming. You see, in bending and embossing sheet of metal by the rubber forming methods, the female die is replaced by the rubber pads. The female die is replaced by the rubber pads. It means this is the female die. The bottom one is the female die, and it is replaced by the rubber pad. That is what I have written. The downward which is replaced, normally it will be a toughened die. So that has been replaced by the rubber die. The parts can be also formed with the laminated sheets of various non-metallic materials and coatings also. There also it is helpful for usages. Now we have seen about the rubber pad forming. Now I am coming to the hydroforming process. The name says it is hydro. We are going to use on the punch to avoid the frictional heat, to avoid the gripness, to reduce the force. We are using some hydraulic fluids there in between the punch and the die. It's very simple. You see, the hydroforming or fluid forming process are otherwise known as the fluid forming. The pressure over the rubber membrane is controlled throughout the forming process with the maximum pressure of reaching up to 100 megapascal. This procedure allows close control of the part during forming to prevent the tearing of the die, tearing of the sheets. The damage can be avoided. How we are avoiding? There I have given the flexibility of 20% resistance, and then cushion effects I have given by using a rubber that is going to have a cushion there, that is having a close contact, avoiding the failure. Here I am giving the same failure avoiding method by using the fluid mechanism. Therefore, a fluid which have a little bit cushions, when you are pressing, it has to dump at one end. Therefore, that dumping pressure is going to resist the material. At the same time, we are giving more force here. So this dumping pressure resistance and this punching force together forms the collapsibility of the sheet which I am keeping here. The sheet which is this blue color. This one is the sheet which I am going to now do the process. So this is converted as a cup. This is converted as a part now. See, this is the cup after that. So this is the fluid. This is the upper die. Die contains the fluid. This is the fluid. So here is we are having a fluid which is going to dump when this is present. When the punching action has been done, it is going to dumping on the fluid, and this fluid goes to resistance. This resistance causes the smooth operation of the creating of the cup features without failure. Therefore, I am using this hydroforming process. So how much we are doing? We are giving a 100 megapascal of maximum pressure we have applied to keep in control. If we know if it is starting to break, this fluid can be taken exit little bit, or the pressure can be monitored, pressure can be controlled with respect to this hydraulic system. We can add a hydraulic system, punching, piston mechanisms, and therefore we can able to control this. In such a way, breakage can be avoided. So this is the product of cup. Finally, we have formed the cup using hydroforming process. Rubber pad forming, cushion created, failure avoided. Hydroforming process, little bit resistance are generated due to dumping pressure, and therefore here also failures are avoided. So the same. So the cup travels with the help of punch. In this way, deep drawing ability are improved. So note that in contrast of the ordinary deep drawing process, the pressure in the dome force on the cup walls against the punch. So that is how this is cup and forces are managed. What are the advantages of rubber pad forming and hydro pad forming? Both are wanted to reduce the failure. That is the advantage. Low tooling cost. Yes, there is a low tooling cost. Flexibility, you see, and easy of operation. This flexibility we need. This related to failure. Failure reduction. And a low die wears because we are using fluid. Therefore, die is not going to wear. One case we are using fluid, and one more case I am using the rubber. So these are the cases I am avoiding the wear. So wear not formed. No damage to the surface of the sheet. Damages. The flexibility is there, cushion is there. Automatically here no damages are not formed. Automatically the sheet is protected. What is the form? A cup. What we need, that we are specifically with a controlled pressure we are going. Capability of forming the complex shapes. If this die is changing, according to that we can be able to convert the shape also. So that is how this advantages of rubber forming and hydroforming efforts. Now I am coming to the next operation of explosive forming process for sheet only. How we are doing? We have taken a container, and the container contains the water, and inside it I have a workpiece which is fixed. And that die contains a cavity, otherwise a shape where what we need. A cup shape I need now. So I have kept the die in form of cup. What happens now? And I am keeping your explosive inside it. I am keeping one explosive inside it, and I am going to fire. When this fire, what happens? It creates some vibrations and heavy, huge force there inside the water. And therefore, this force will impacted here. This force will impact at all directions, but also impacted here also. In such a way, it is more convenient, more easiest method for the sheet metal, because sheet is very thin, and we may consider this, we are keeping the explosive in the water, and this explosive are wasted. Not like that. These explosives are exploding capability, environmental are protected. At the same time, what we need, we have to do the forming operations for the sheet. And less energy is more than enough to convert to the sheet metal forming operations. So, but that small quantity of explosive we are using here, that energy what is generated by the explosive is more sufficient to convert this sheet less than 6 mm to the cup. That is okay. But not for a blade. If the blade is increasing, again the explosive quality and quantity to be increased in such a way, a large energy to be generated. So those things. This is one of the form. And another form here, the form is different. We have the rectangular box which contains the water. In such a way, here we have a large box, a rectangular straight box. Here I am keeping the, here I can able to keep the explosive. Here I am keeping the explosive. What happens when it is fired? It is going to give the impact over here. It is going to keep impact over here. Therefore, it pushes the workpiece, pushes the sheet which is less than 6 mm, and it is going to punch over there, and then we can able to generate the forming operation. So it will go like this. It can be generated. So such possibilities are there. Explosive energy is used for metal forming process. Yes, that is what. The sheet metal blank is clamped over the die. It is clamped over the die. Assembly is immersed in the tank with water. This total assembly is immersed in the water. We have built. A rapid conversion of explosive charge. The rapid conversion of explosive charge when it is blasted into gas generates a shock wave. Generates a shock wave. That is what? Like this. A shock wave was generated. So it will be helpful for creating an impact over the specimen sheet. This pressure of this wave is sufficient to form to the sheet metals. So that energy is sufficient. The energy is wasted, but the environment is safeguarded. So and then we are completing this sheet metal operation in very simple for the sheet. The remaining part will continue in the next session. Thank you.